Hello everyone, this is Sam from HiPy. We're here again with another video. Today we're going to be learning the other basics of Python. We're going to learn more of the programming elements and how to get Python to do things that kind of we really don't want to do ourselves. So I'm going to rename this basics 2. You can find all these notebooks in a folder in the GitHub, and we're just going to go over two things, and then we're going to look at the worked example that I want to go through, and that should teach us almost everything we need, or the main things we need to know about programming in Python. So there's two things that aren't in the worked example are function definitions and for loops. So when using Python, we'll use a load of functions made by other people and by the Python people just to kind of make our code just run a bit nicer, and they do things for us that that happen over and over again, and they're common kind of functions that we want to kind of save and use for later. So in our code, sometimes we want to kind of do the same thing. We want to we have a problem that takes one or two or any number of inputs. It does something very similar to those inputs, like in a number of different situations, and then it gives us the output of that process. So, for example, one function is the power function, which takes the first number and puts it to the power of the second. So if I print pow 34, we should get 3 to the power of 4, which is 81. So the function takes two inputs here, which are usually called arguments, and it'll do some operation or do some process within that function, and then it'll return a value or kind of like an output. So in the case of matplotlib, the return that we're getting is a graph, essentially. So we can look at how to define our own functions here. I'm going to do a very, very simple example, a function that adds two numbers, just for the sake of example, but you can kind of see very quickly how these can become very complicated and very neat little examples. So we have the def keyword, so it's short for definition, and we're defining add, and then we're taking in two numbers a and b, and then we're pressing the colon button, and we need the colon button here because that's the syntax. Then if we press enter here on most of the programming environments, we'll see that we get this little indent here, and that's really important for the definitions because otherwise Python won't understand what's going on. So I'm just going to go double enter just for the convenience of looking at things, and then we're just going to say return a plus b. So you can see here what the syntax is like. We're taking two inputs a and b. These aren't actually kind of like objects within Python, but they're kind of dummy variables that we're using. So Python won't think of a and b outside of this context. In fact, if we run this and then we print a, we see that a isn't actually defined. But when we basically use these as an example to Python of what we want to do. So we can now type in print add 34, and then we get 7. So that's really good, and we can do it the other way around as well because it won't matter, because it doesn't matter which order you add things in. So that's definitions. There's going to be some more resources on definitions in another guide, because there's a lot more things that you can do with them. You can actually pass these definitions as arguments to other functions, which is where it gets really complicated. But for now, let's move on to the for loops. So looping is what we want to do when we have a really boring operation or process that we want to perform over and over again for a set amount of times. So for example, if we wanted to take the sum of the first 100 numbers, we don't want to sit there and type in 1 plus 2 plus 3 plus 4 and whatever. We could define a function for it. There is a formula for finding the first sum of the first n numbers, but if we want to do it using a for loop, we can do it using the following syntax. So we type in for, and then we type our dummy variable. So I'm going to type in I in, and then we need a list for it to iterate over. So for now, I'm just going to write range 101. So actually I should do this. I'm going to do this but ignore this error. So range 101 is a function which takes one argument, and then this needs to be list actually, because that's a Python 3.6 change. What's happening here? I'm missing. Okay, there we go. So range 101 returns a list from 0 to the number minus 1, essentially, which might be a little bit confusing at first, but here we go. So we have range 101 gives us the numbers 0 through to 100. So what this is saying is for I in this list, so it's going to say, well, I is 0, and then it's going to do whatever we have in this indent here, and then it's going to say, well, I is now 1, and it's going to do whatever that's in there, and I is 2, and it's going to keep on going through all of these numbers up to 100. So if you want to work out the sum of the first numbers, we can have a variable called number, which we're just going to start at 0, and then we're just going to say number is equal to number plus I. So what it's going to do is it's going to say I equals 1, and then 0 equals 0 plus 0. Good. I equals 1 will give us number equals number plus 1, so that's 0 equals 0 plus 1, so number's now 1. And then I equals 2 will give you 1 equals 1 plus 2, or number equals 1 plus 2 rather, and we're going to get number equals 3. And we keep on updating our definition of what number is to get the new numbers essentially, and then we can just print what number is at the end. So print number, and if we shift enter this, we get the sum of the first 100 numbers. So that's really easy. So now we're going to get onto the more complicated example, which is the prime decomposition algorithm and kind of program. So any number, any kind of whole integer number can be split into the product of prime numbers. So a prime number is a number that's only divisible by itself and 1, and any number can be split into a product of these numbers. So for example, 4 is 2 times 2 because 2 is prime, 13 is a prime number so it's just 13, 15 is 3 times 5 because 3 and 5 are primes. So we want to find a program that just gives us the decomposition of these numbers. Sorry about that. So we're going to start by doing 3 things, and you'll see that this isn't very efficient, but it's a nice way of teaching us a couple of other points about Python. So we have, we're going to define our number here. So I'm going to use the number that. I'll just kind of spam my keyboard a little bit. And then we're going to set up a variable called primes, which is just going to be an empty set, or an empty list, sorry. And then we're going to have a test number, which is just going to be 2. So you can set this number to anything you want, but the prime and the test variables have to be the same. And then we're going to say while true. So this is another loop, and it's going to, the while loop, instead of iterating over things in a list, it's going to continue doing the loop while this condition is true. So usually you would have something like a is less than 10, and then you'd have some kind of manipulation of a or something down here, and you'd say a equals 0 up here, and then you'd say like while a equals 10, or while a is less than 10, do something, then a plus 1 kind of thing. But for now we're going to do a neat little trick called, well, with the true. So it's going to keep on doing this loop unless we break out of the loop, and then we're going to do a few things that might look a bit weird at first, but it'll be clearer once we get around to it. We're going to say if number is equal to 1, which is an if statement. So the if statement does the code below in the indented block if and only if this condition is met. And then for the equals of the logical kind of operator, we have to use double equals here because single equals is already used for assigning variables. So we have if number double equals 1, so we're saying if our number equals 1, then we are going to print to the console done. And then we're also going to print the list of primes. That's not primes. And then we are going to break, and what break will do is it'll break out of this while loop. So it means that we're just ending the program only if we find the decomposition of the primes, because the number will equal 1, and that'll be a bit more clear later. So what happens if the number doesn't equal 1? Because it's not always going to equal 1, it doesn't equal 1 straight away. We need an else if. So we have elif, which stands for else if, so it's another condition. If the number is divisible, well, if the number modulo the test equals 0, so this is saying if the number is divisible by our test number, because the remainder equals 0, and in the indented block here we're going to write primes dot append the test number. So what this is doing is it's a method for the list, the append method, which is going to add the test number into the primes list. And then we are going to divide the number, which is like this. So this is the shorthand way of just saying this. So what we can do is if we have a kind of like a variable that's going to be updated with the same variable, just with some simple operator done for it, we can move this operator over here and then just delete this. What this is just saying is update number with number divided by test. So then we need the last if, because we have one more situation where the number is not divisible by test and the number does not equal 1, and we're just going to say here, just add 1 to the test number. So let's think about what this program does before we execute it, because it's really helpful to do that, and it's a good exercise to try and get your code to run without errors and just kind of like wade through and just work through the errors. It's good practice to do it this way. So let's see what happens with some trouble numbers. So the first number I can think of that's a trouble number is 13. What happens if we put a prime number straight away in the program? So we get 13, the number doesn't equal 1, the number doesn't equal our test number, so we move on to the last one, we just add 1 to the test. That's going to keep on going because 13 isn't divisible by anything until the test number gets to 13, and then we hit this one, we get number is divisible by test equals 0. That's true because the number will be divisible by the test number because it will be 13, and we are then going to add the 13 to the kind of primes list, and then we're going to divide the number by the test number. So here we're going to add 13 to our primes, and then we are going to divide 13 by 13, which will give 1, and then the next time we go through we will see that number does in fact equal 1. We're done, we print the primes and we break it out of the loop. So that's good. Another problem that could happen is what happens for repeated primes. We'll see what happens with 4. So the test number is 2, the number doesn't equal 1. The number is divisible by 2, so we add 2 to the list. We then divide by the number, so we get 2 back. Then we go back up here, and we get number doesn't equal 1 yet, so we don't do this. The number is divisible by 2 because 2 is divisible by 2, so we add another 2 to the list. Then we divide by the number. The test number, sorry, and then we go back up here, so now we have 1 and 2 2s in the prime list, so we get number equals 1, yes, done, print the primes, break, good, everything sorted out. So if we now run this code, we'll see that we, primes is not defined. That's because I haven't written primes here. Okay, there we go. So we can see here now that we just get the prime decomposition of this number here. So my challenge to you, this went a bit fast, but my challenge for you is, can you make this into a function definition, perhaps with the help of the written resources that we give you, or with the help of other written resources? Can you make this into a function definition, and also in the actual written kind of resource we have a exercise which is really common for programming challenges, which is making a program that takes any number in and then returns fizz if it's divisible by 3, buzz if it's divisible by 5, and fizzbuzz if it's divisible by both 3 and 5. So the 3 challenges that we give you are: can you make a function that does this? Can you set a loop for the function that runs for the numbers 1 to 100? And then using the map function, which is going to take a little bit of research by yourself, can you do the same as the loop, but just not using a for loop or a while loop? So the map function is a really cool way of you basically take a list and a function in, and then it applies the function to the entire list. So that was this video. Sorry this was a little bit long and it was probably way too fast, but just kind of like break it down and take it slowly, because these are really important parts of programming, and if you enjoy this you'll love programming in general. But next time we'll look at some nice libraries that we can use, and hopefully I'll see you then, and most importantly, have fun.